Hi, I'm Subhradeep Chatterjee. I am the instructor for the course Computational Thermodynamics and Kinetics of Materials. Now, as materials engineers, we turn materials into useful um, components, basically engineering products. And when we do processing operations with materials, we demand that the ultimate material should have certain properties. Now, these properties come from the structure of materials at a microscopic scale. We call this as microstructures. The building blocks of microstructure is what we call as phase. Now, this phase are phases that constitute the material, and their amounts, their distribution, size, shape, spatial arrangement is what determine the properties of the material. So, to understand the properties, we must understand phases. And in the first part of this course, we'll talk about given certain external conditions like temperature or composition of the system, how which phases will be present, what will be their amounts. So this constitutes the first part. We get the answer to this question using certain constructions which we call as phase diagrams. And phase diagrams are nothing but maps of different phases in the system as a function of important parameters like temperature or composition. In the complex systems, material systems used in today's engineering application, the systems typically contain more than three or four elements, in which case we go into the diagrams in the conventional sense cannot be drawn, but we can still express this relationship between the external variables and the phases through what we call as phase equilibrium. So these are generalized phase diagrams. And this approach to calculate phase diagrams from the thermodynamic principles is what is known as CalFAD, which is a short term for the phrase calculation of phase diagrams. In this course, we will learn the principles of CalFAD starting from the basic definitions of thermodynamics, materials thermodynamics, and then learning about solution models and applying thermodynamic principles to find at equilibrium what will be the phases will be given for a given combination of temperature and composition, the phases present in the system as well as their amounts. Now, in this description, what is missing is the factor of time, and that is where the second half of the course deals with what we call as kinetics. Now, we will establish a connection between thermodynamics and kinetics using basic flux laws, which are starting from a thermodynamic description of the system, which and combine these flux laws with conservation laws, which tell us how the system would evolve as a function of time. And for example, that will tell us how the phases, the amounts of the phases will change with time, or how much time should I do the operation to get a certain amount of a phase. It will also tell us, for example, we can combine kinetics with ideas from phase transformations to get an idea what will be the size or length scale of the phases inside a material and their distribution, how it changes with time. So all this we will talk about in the second part, which will be related with kinetics and phase equilibria, phase transformations. Now, to answer all these questions, we will give examples from real life alloys, and these alloys are too complex to be analyzed using simple solutions from thermodynamics and kinetics. We will cover the simple solutions, but our effort will be geared towards solving them for more complex systems. And often we cannot solve, or mostly we will not be able to solve them analytically, so we will need to use numerical methods. In this course, we will outline the basic approaches, numerical approaches to solving the system, and then switch over to using a software, commercial software to solve those problems. Although we will use a software called ThermoCalc, a free version of this commercial software is available for download for students. Although it has a slightly lower or a limited capability in terms of the number of components that you can use and the calculations that you can do. If you are interested to dig deeper, you can always do some little bit of coding and set up a software environment to use something like open source programs like OpenCalFAT or PyCalFAT to solve the equation using publicly available thermodynamic databases. So this is what we are looking at to learn in this course, and your learning outcomes will be evaluated through quizzes and a final project where you will pick up a problem of your interest and solve it using some thermodynamic and kinetic solution, and you will produce a report explaining why this problem is important and how you solved it, what are the results, discuss their significance, and present these findings through a final presentation. So this is all what we are looking forward to this course. So I welcome you all to join this course and hope to see you there.